class we are going to learn about the topic projectile motion. In simple, movement of an object in a two-dimensional plane which is going to have an initial angle with the x-axis. That means that the object is going to be projected with the horizontal at an angle theta. So, as a result of it, the object is going to follow a path which is going to be a curved path, which we used to say that as parabola. So, whenever we are using this term projectile motion, that means that the object which is being projected is going to follow a parabolic path. Now, you must be staring at me and you must be thinking what I'm talking about, right? Very simple. Apart from this, all physical terms, an angle, projectile, parabola, I'm just coming out from all this physical and mathematical terms, and I'm just trying to show something over here, and your favorite one as well. Just have a look at it. You would be able to see here in the frame that the true peoples who all you are seeing over here, they are trying to pull the tree towards the backward, and then they are using a rope for it. You would be able to see that they are trying to pull it back and the mass is being attached on that. That is, the persons who are all standing on that is going to be the mass over there, right? So, we are attaching a mass. That means that we are having a projectile which is going to have a mass there. And the projectile is going to be pulled. That is, it is going to be pulled backwards to form an angle theta with the horizontal. That is, it is being pulled like this, right? If it is the horizontal, then what is the angle you are going to have? That angle of projection will decide that whether the soldiers are going to reach the castle top over there or not. Right? See, at that time when it has been before 200 to 300 years, or it may be 1000 years before, they are not aware of this fact, or they were not calculating this exactly in numbers. The assumption, that is, by looking at that distance itself, people are capable of calculating the distance and they are forming the angle according to that. So that if the angle what is made over here is more than enough for them to reach over there to the castle, as you're seeing it over here.
Let us have a close look at the same catapult what you have seen in the previous clip over here. You could be able to see that the projectile of mass 90 kg is being attached with the throwing arm, and the throwing arm is going to be having a counterbalance, and it is going to be projected at an angle now, so that it is going to reach a distance of 300 meter away with the particular initial velocity with that angle. I'm just showing that again to you. Let us look into few more examples for this projectile motion. Then we will be exploring the terms associated with the projectile motion one by one, and then we will be going for the derivation, that is the formulas which is associated with the projectile motion. That also we will be calculating it. First, let us see what is projectile motion. The word projection or projecting something means that an estimate or forecast of future situation. That means that by estimating where the object should reach, if the object is being thrown, then that means that the object is being projected. So that whenever the object is going to be thrown at any of the earth surface, as a result of the throwing, if it is going to follow a curved path, then the object will said to be in projectile motion. Notice the term over here that the only force which is going to act on that is going to be the gravity. Now there must be a question in your mind. Then to throw that object, we are giving an initial force, right? See, the initial force is the one which is making the object to move, but the force which is making that to follow the curved path is only the gravitational force. At each and every instant, the gravity is trying to pull that object towards the downward, which makes that to follow that curved path. That is why we are defining the projectile motion as the path followed by the projected object is going to be curved, and due to the gravity, then it will be called as a projectile motion. Right? Now let us look into few more examples for this. Motion of a snowboarder descending from a slope. You could able to say that descending from a slope, where he is also being projected at an angle with the horizontal what it is going to make. Am I correct? Yes. Now the next example is motion of a rider performing a bike stunt. We'd have been seeing this in circus. Hope so you would have been gone for circus, right? You guys could able to think about it that whenever you are going for a circus, a man in a bike will be doing such a stunts over there. There also the man with the bike over here with the horizontal at an angle, he is going to project himself. That is, the object over here is the bike and the person together, right? Now the next example, very simple, the water jets which is coming out from the nozzle. So what is the nozzle we are going to have over here? Those nozzles are going to be at a particular angle with the horizontal, which makes this projection of them like a parabolic path is possible. So once again they are acting as the projectile over here, right? Now whenever we are talking about the projectile motion, we are going to have some assumption in the sense, in a practical situation they are going to be actually negligible, so that we are going to take them under the consideration that they don't exist or they are going to have a negligible value. For example, the effect due to the air resistance is negligible. So in the previous example what we have seen, either in the example of the motorbike or it's going to be in the terms of water, if there is a very high air resistance is going to be there, it's not possible for the object, that is the bike rider or the water, to follow that path even. Am I correct? They will get distracted, scattered out due to the opposition force, that is the air resistance what we are going to have. Yes, so this is the reason why the air resistance is being taken as negligible. And when it comes for the next term, the effect due to curvature of the earth is negligible. Let me show you that with the previous example itself. If you are going to look at this previous example over here, see what is the line I'm having over here. I will take this as a horizontal line, right? But if it is going to be a earth surface, then it should be taken as a curve. Yeah, but we are not considering that as a curve, as we guys are staying on the earth surface, and compared to the diameter or the arc length of the earth, the place where we are staying and these projectiles are being projected are going to be at a very low distance. So what is the curve of the earth that we need not to consider? We can take this horizontal portion as a straight line itself. Yes. Now the next assumption is the effect due to the rotation of the earth is negligible. Imagine that if you are going to include the earth rotation over here, it means that the motorbike person is going to do a stunt on the rotating ball. Then is it possible for him to do it? No, right? So the speed at which the earth rotates, that is of a different time and frame. We are on the earth. We so that we are not able to feel the rotation of the earth. That's the same reason why we are taking that as a negligible one over here as well. Then the acceleration due to gravity is constant over the range of motion. The meaning for this is gravity on the earth's surface is 9.8 meter per second square, right? This value will vary for sure with height, but the projected objects what we are going to have most of the time will not reach that much maximum height, so that they can have the variation in the acceleration due to gravity. That is the reason why we are saying that, or why we are taking here that the acceleration due to gravity is going to be taken as constant. Could you able to understand? Now I'm just showing you an object which is going to have a projectile motion will follow this projectile path. You could able to see the object is going to be projected with the initial velocity v with the horizontal at an angle theta. So this theta is called as the angle of projection, and the velocity with which the v starts is going to be called as the initial velocity. From the starting point till the ending, what is the distance which is going to be traveled by the projectile is called as the range of the projectile. And what is the maximum height the object could able to reach is called as the maximum height of the projectile. And to move from the starting point till the ending point, it will be taking a particular time, right? During that time, the ball, that is the projectile or the object, is going to be in the air only, so that the total time taken over here will be taken as the time of flight. Could you able to understand? Now whatever I told you, one by one I'll give you the definitions for them. Yeah? Could you able to follow me? Any object which is projected in air is called as a projectile. That is the object which has been projected, right? So here the R projectile is going to be the ball. So in the upcoming slides I may use this as a ball or projectile. Both of them means the same. Yes? Now you could able to see that the point at which the object is going to be projected with the horizontal is called as point of projection. Got it? Now the next term we will see the velocity of projection, which I told you as the initial velocity, or we can call that as velocity of projection. That is, while projecting the object, what is the velocity we are giving that? That is, while projecting the object, what is the velocity we are giving to that object is called as the velocity of projection. The next term is angle of projection, which I told you earlier, the angle at which the object has been projected. Next, trajectory, or we used to call this as parabola. Parabola is a general name in mathematics, but the path followed by the projectile will be normally termed as trajectory. The path, the parabolic path. Okay. Now the time of flight, as I told you, from the starting till the ending, for a particular time the object will be in air. Air means it's flying, right? So that we are calling that as the time of flight over here. Yes. Now what is the maximum height is nothing but, as I told you, on the y-axis what is the maximum distance covered by this object is called as the maximum height of the projectile. Horizontal range is nothing but in the x-axis what is the total distance traveled by the object, that is the horizontal distance is called as the range. Now we must understand one more important term whenever we are trying to talk about this projectile motion. What is that is nothing but, we always used to consider the components of the vector, because if you're going to take the figure over here, velocity is the vector quantity. With this vector quantity only, the object is being projected over here. So the projected object will be having two components associated with that. One will be Vy sin theta, the other one will be Vx sin theta. So here we are going to have two components. We need to find, whenever we are finding any of these terms associated with the motion, if it is going to be a vector quantity, then obviously based on this component vectors we need to find the answer, right? Now these component vectors we are going to take in terms of their trigonometric ratios, which is nothing but the sine and the cosine values. So if you're going to consider the x and y, how this velocity varies over there is the very important thing about this projectile motion, which we are exploring in this slide now. Now if you're going to look at it, is horizontal and vertical motions are interdependent? Look at that. Both pink and yellow balls are falling at the same rate. Am I correct? You were able to see the ball and the time interval associated with them, correct? The yellow ball is moving horizontally while it's falling have no effect on its vertical motion. You could able to see that the vertical motion what you're going to have, that is the same thing what you're seeing. It means horizontal and vertical motions are independent of each other. That means that if you are going to have the projectile over here, that is the ball which is being kicked over here, what you are having now, if you are going to have the ball over here, then the maximum amount of gravity it will be having because it's on the earth's surface. And when it's been projected with the velocity, the vertical and the horizontal component we will have. Do remember, in the horizontal direction, what is the velocity or what is the motion the object is going to have throughout the space is going to be maintained uniformly. So whenever you are going to have a projectile motion, the horizontal portion associated with that or the horizontal component associated with that will remain constant. As we are taking here, the motion is going to be taken as uniform acceleration or uniform motion, uniformly accelerated motion or the uniform motion. The along the x-axis, whatever the component we are going to have, that will remain constant, right? So if I'm going to split this as v sin theta and v cos theta, then v cos theta will always remain same. There won't be any change in its value. But when it's going to come for the v sin theta, at this point there is no vertical velocity because it's in the horizontal, 0. Then with the force what you supply to it, slowly it will be having an increase in value, but as it's trying to move above, at each and every point it's having an increasing height. That means that the gravity will try to pull it towards the downward with as much amount of force. At a point what will happen, when it's going to reach the maximum height, the amount of vertical velocity acting on that will become 0. Very good example for this is when you are going to throw a baby in the air. At a particular height, the baby will go for the rest for a fraction of a second with a cute smile, and then the baby will be coming back to your hand. Am I correct? You could able to see for a moment the baby will be stopped or the baby will be floating over the height, right? That's the same thing applicable to all kind of object. Whenever they are reaching the maximum height, at that point the total amount of velocity associated with that will become 0. But over here the horizontal component remains 0. So v cos theta will be there, v sin theta will be 0. Then when it's going to come for this point, slowly the ball is coming towards the gravity. That means that the gravity is trying to pull it towards the down, so that it will be having a furthermore change in value of the acceleration due to gravity on that, and finally it will come to rest, right? Now the same thing, I'm just trying to show you how the horizontal and the vertical motion is going to vary with each other. I'm just trying to show that in frame by frame here. Look at it, I have splitted the velocity of projection into Vi and the Vx, x and y components over here. Look at the x component as well as the y component in this side. Now in the frame by frame, you could able to see that frame 2. The Vx, if you're going to look at it, that remains same. But you could able to see that initially the value of the Vy were increasing. I'm just going back once again. Look at it. As the object is going to be in the initial state, Vy and the Vx you could able to see. When it's going to reach the first portion of the ball, you could able to see that Vx, Vy. So Vy got increased and Vx is also getting increasing. That is variation in the value. And when it's going to come for the next point, you're able to see Vy reach the maximum. That is, it's going to become 0 here, right, at the maximum height. But it is having continuously a value associated with that increase in the same amount. And when it's going to come for the next point, look at the V2y position properly. It's going to have a decrease in velocity because it's moving towards the down, right? So again it's decreasing, further it is decreasing and it becoming 0, right? But the Vx value what you hold over here remains same on the x-axis. It varies continuously the same, right? So that's how we are having the final figure over here. So at each and every position, if you are going to consider, the value of the Vx and the Vy talks a lot, and it tells us very clearly that the horizontal component remains constant throughout the motion, but the vertical component is going to vary point to point, right? By taking this into account, we are going to derive the equation now. So the conclusion is here. In a projectile motion, which is the combination of two motions, which is nothing but the horizontal motion with constant velocity and vertical motion with constant acceleration, right? That is acceleration due to gravity. Now let us get into the equation of trajectory as well as the component whatever associated with the projectile motion. The horizontal distance traveled by the projectile in time t along the x-axis is the horizontal distance, that is on the x-axis what is the total distance we are having, that we are trying to find. That is called as the range we said, right? So that x is equal to, distance will be given by what formula? Velocity into time. That's the same thing we have here. As it is being represented as the horizontal, then we are using it as the Vx over here, horizontal, and the distance is also on the along the x, so it's been written as x. Now the horizontal velocity will be given by what? The horizontal component, which is Vi cos theta over here. I wanted to know the time, so that I'm just rearranging it, which is giving me x over Vi cos theta, or the Vi is the initial velocity, so that we can write that as u as well sometimes. So you can say that as x divided by u cos theta also, which is our first equation. Now let us get into the next equation. The vertical distance traveled by the projectile in time t along the y-axis. So we are trying to find out the vertical distance traveled by it. Obviously vertical distance or the distance associated with the time will be given by the relation s is equal to ut plus half at square. Here the s is going to be the distance travel in the y, so it's been taken as y instead of the s, and Viy into Vt, which is the initial velocity in the y-axis into time minus half gt squared. The object is moving towards the upward, so the amount of gravity acting on that must be negative. That is why there is a minus sign over here. Now the y-axis component, I'm replacing it over here, which is going to be Vi sin theta into t minus half gt square. Now the above one, what is the value of the t we found in the equation 1? We are going to substitute that over here for this t value. So what I'm going to get? Vi sin theta into x by Vi cos theta. So Vi and Vi will get over, sin by cos is going to be tan, and the x is the same, minus x by Vi cos theta the whole square, right? So that it will become what? Vi squared cos squared theta above x squared you're going to have. Am I correct? Now if you're going to look at it over here, the above one is called as the equation of the trajectory, that is the equation of projectile motion. As the initial velocity and the angle of projection and the acceleration due to gravity are constant for a particular projectile motion, then the tan theta will be given by alpha. That is, we are taking that as the single term so that we could able to get a common comparison for this equation of the trajectory. And the second whole term we are taking that as beta, which gives us the quadratic equation, right? Obviously the solution of this quadratic equation is going to be a parabola, right? So that we could able to say that what is the motion we are having here is going to be the projectile motion only, right? Now we are coming for the next one, which is the equation for time of flight. So the same terms only we are going to find over here, but the time for the object to be in the air, it is going to be. So the vertical distance traveled by the projectile in time t along the y-axis, as usual we are writing the same one. Vi is going to be Vi sin theta. I'm substituting it over here, and this is my time of flight, so I'm just replacing it to have a variation for the t over here, and I'm just rearranging the equation. Why we have written 0 here, do you remember? At the maximum height, what is the velocity we have is going to be 0, so that's going to be 0 over here. So the rearrangement is going to give us the time of flight over here. Now this is the equation for time of flight. For symmetrical parabolical path, the time of ascent is equal to the time of descent, that is the time at which it is going to reach the maximum height and the time with which it's going to come from the maximum height to the down. Both of them should be equal to each other. So when you are trying to find either time of ascent and time of descent, then it should be half of time of flight. That means that time of ascent plus time of descent is equal to the time of flight. So if you want to find the time of ascent or time of descent, that will be given by time of flight divided by 2, which is nothing but Vi sin theta divided by g, or you can call that as U sin theta divided by g, right? Are you all with me? Can you able to follow?